Welcome to the second lecture on applications of derivatives. So we are discussing tangents and normals in this lecture. We have already discussed the procedure to find tangent and normal equations, but we'll consider the next part of the chapter here. So let's begin with lecture 2. Now, let's take a quick recap of how to find the equations of tangent and normal. So I have already mentioned this procedure to all of you. And the method is very simple. Step 1 is to differentiate the given curve and obtain the value of dy by dx. Okay. Then step 2, of course, was substitute the point of contact x1, y1. This is the point of contact in the expression of dy by dx and denote it as m. So m is nothing but dy by dx at point of contact, and that is nothing but slope of tangent. In step 3, we use slope point form, that is y minus y1 equal to m into x minus x1. Again, remember y1 and x1 are coordinates of point of contact. M is the slope of tangent. And in step 4, we use slope point form, that is y minus y1 equal to minus 1 upon m into x minus x1, and simplified to obtain the equation of normal. You should remember why I had taken minus 1 by m here. Okay, now, so let's talk about today's class. So today's class will focus on angle of intersection between two curves. Now, in order to find angle of intersection between two curves, you need to find the angle of intersection of tangents to the two curves at the point of intersection. Now, what do I mean by that? So once again, let me repeat. You need to find the angle of intersection. So the angle between the two tangents, the angle between the two tangents at the point of intersection. This is nothing but angle between two curves. So have a look at this diagram. I have taken two curves C1 and C2. The curve 1 is of course y equal to f of x, and curve 2 is y equal to g of x. Now look at the tangent. PT1 is tangent to curve C1 and PT2 is tangent to curve C2. Theta is the angle between PT1 and PT2, and hence I can say theta is the angle between C1 and C2. Now, there are 2 to 3 things that you should remember. First of all, slope of PT1. Now, slope of PT1 by definition is going to be M1 equal to tan of psi of 1, because this is the angle made by this tangent with the positive direction of x-axis. So by definition, this is the value of slope of PT1. Similarly, slope of tangent PT2 is going to be M2 equal to tan of psi of 2. So here are the 2 things that you should remember. And there is one last thing that all of you have to note, that if you look at triangle PT1 T2, then you can see that this angle theta plus this angle psi of 2 plus this angle. Now, if I want this angle, see, this complete angle here is 180 degree, that is pi radian. So if I want this interior angle to the triangle, that's going to be pi minus psi of 1, because this exterior angle is psi of 1. So all of you must have understood this. I'm just going to write it quickly. Pi minus psi of 1, and that has to be pi. Why is that? Because sum of all angles of a triangle is supposed to be 180 degree, that is pi radian. Now just cancel this out and transfer the terms. So you should get theta is equal to psi of 1 minus psi of 2. Now you have to remember these 3 things, and then you can proceed to this portion. Now just understand, I have written everything here. So let's go through this quickly. Right. Now there are two curves, C1 and C2. They are meeting at point P. They are meeting at point P, and PT1, PT2 are two tangents to the curves C1 and C2. Okay. Slope of PT1 is tan of psi of 1. I have written it over here. Okay. So that is tan of psi of 1. And slope of PD2 is of course tan of psi of 2. Now we have also concluded that theta is equal to psi of 1 minus psi of 2. I have already got this value over here. Now, if I apply tan to both sides, I can get this as tan theta is equal to tan of psi of 1 minus psi of 2. This is nothing but tan of A minus B, which can be expanded as tan A minus tan B upon 1 plus tan A tan B. So tan theta is nothing but then mod of m1 minus m2 upon 1 plus m1 m2. You might think why I have applied mod here. So the reason why I applied mod is because I need to consider the acute angle between the two tangents. And as you know that if theta is acute, tan has to be positive. So I have to apply mod to this expression in order to make it positive so that theta becomes an acute angle. So if I need theta, I can just transfer tan inverse to RHS in order to obtain the final answer. Now, I think I have written one note here, and for that I just need to remove this portion. Now, just see here. Yes. So notice that if two curves are, the two curves are said to be orthogonal, if theta is equal to pi by 2, that is m1 into m2 is equal to minus 1. Now this is again easy. Two curves are said to be orthogonal means two curves are said to be perpendicular if the angle between them is pi by 2. But as you can see, m1 into m2 has to be minus 1 because these two tangents, if they are perpendicular, then and only then the two curves will be perpendicular. So simple, but remember this is an important result. Now, I have just simplified this for all of you. I have made a simple stepwise procedure in order to obtain the angle of intersection between two curves. So I will look at step 1. So obtain the point of intersection of two curves. This is our point P. You have to obtain this point of intersection. This can be done by simultaneous solving of two equations. Then in step 2, you have to differentiate the two curves separately, of course, and substitute the point of contact, that is point of intersection of the two curves, in them individually, one by one, individually, in order to obtain m1 and m2, that is slope of tangents. Then in step 3, you have to use the result tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. We have already talked about it, where theta, of course, is the angle between the two curves. Again, very simple. So follow this procedure of 3 steps in order to obtain the angle of intersection between two curves. Now, we are going to practically apply this in this question. And before I begin, you can pause the video for a minute, try to solve the question on your own if you can. If not, then just continue with the solution here. Right, so the solution. Okay. I think, yeah. Right, solution. So, just consider the two curves, x into y is equal to 6. Let us call this as 1. And x square y equal to 12. Let us call this as 2. Now, you need the angle of intersection between the following curves. So, first of all, you need point of intersection according to our step 1. Point of intersection, of obtaining that point, you will have to maybe divide these two curves. So, let's divide them. 2 divided by 1. Looking at the equation, I can then apply a possible technique, and that always depends on certain condition. In this, I can just write in this way. Right, so y gets cancelled when x gets cancelled, and you have x is equal to 2. Very simple. Now if x is equal to 2, you can obtain the value of y also. How come? You can substitute that in 1. If you substitute that, you will get 2y is equal to 6, means y is equal to 3. So x equal to 2 and y equal to 3 means coordinate of point P, that was our step 1, is x1 comma y1. Now let's start with obtaining slopes m1 and m2. So for m1 and m2, let's differentiate this. So you'll have to apply product rule, x into dy by dx plus y is equal to 0. Now for that, in the next step, I need to substitute x is equal to 2 and y is equal to 3. So 2m, as soon as I substitute point of contact, this dy by dx becomes m. In this case, it would be m1 because I am considering the first curve. So 2m plus 3 is equal to 0 means m1 is equal to minus 3 by 2. Then for m2, this is for m1, you have this value. For m2, let us consider x square y equal to 12. Let us differentiate this. Again, you'll have to apply product rule. So x square dy by dx plus y into 2x is equal to 0. Now let us substitute the point of contact in this. Again, the point of contact is the same for both the curves. It is 2 comma 3. So as soon as you substitute it, it becomes 4m2. I hope you have understood this step. Plus, then this becomes how much? This will be 4 into 3, that is 12, and that is equal to 0. So how much is m2? M2 is coming out to be minus 3. Okay, I hope that I have written this correctly. Now, let's just write the last term. So this tan theta is mod of m1 minus m2 upon 1 plus m1 m2. Okay, so take the LCM here. That is going to be how much? It is 6 minus 3, that is 3 by 2 upon how much is that? 2 plus 9 means 11 by 2. So that is coming out to be how much? That is coming out to be 3 by 11. So what is theta then? Theta is going to be tan inverse of 3 by 11. Okay, this is the correct answer. Now let's proceed to question number 2. So find the angle of intersection between the curves x equal to y cube, 6y is equal to 7 minus x square. Okay. So y equal to x cube is the first curve, and 6y is equal to 7 minus x square is the second curve. Again, I need to solve this simultaneously. So I can replace this y over here. So I can get this as 6x cube is equal to 7 minus x square. Now, by trial and error method, because you must realize that we have to solve this by easiest procedures, and I see that if I substitute x as equal to 1 directly, I can get 6 over here, and I can get 6 over here. So LHS is equal to RHS. Therefore, x has to be 1. If x has to be 1, let's check the value of y. You can substitute it in first expression. If x is equal to 1, y is also equal to 1. And in easiest way, I have got the point of contact as 1 comma 1. So point P is nothing but 1 comma 1. Let us differentiate for m1. Let us differentiate this. So dy by dx has to be 3x square. Okay. Substitute the point of contact in this. So m1 is equal to 3. Okay. For m2, let's just write this as differentiation of this part is 6 dy by dx is equal to minus 2x. So what is x? X was of course 1. So if I substitute this over here, this is going to be 6 m2 equal to minus 2. So m2 is equal to minus 1 by 3. Now check that m1 into m2 is minus 1. Therefore, I can say that the two tangents are perpendicular, and hence curves are orthogonal. So of course, what is theta? Theta is therefore pi by 2. I hope this solution is clear. Let's proceed further. Now, let's talk about the next part. If theta denotes the angle of intersection between two curves y equal to 10 minus x square and y is equal to 2 plus x square at the point of their intersection, then mod of tan theta is. Okay, this has appeared in the JEE examination in 2019. Okay, so let's just start with the solution here. Let's look at the given data. So there are two curves, y is equal to 10 minus x square. This is of course 1, and y is equal to 2 plus x square. Okay, this expression is of course 2. Right, now you need the mod of tan theta here. Okay, so that theta denotes the angle of intersection. So we have to apply the same procedure here what we have applied before. So you can just equate equations 1 and 2 because their LHS are equal and you need to obtain the point of intersection. So you have to solve them simultaneously. So this is 10 minus x square equal to 2 plus x square. This is absolutely right. Transfer this to LHS. You'll get this as 8 equal to 2x square. That is x square is equal to 4. That is x is equal to plus minus 2. Now, in order to obtain the value of y, I need to substitute that in any one of the two equations. So suppose I substitute that in equation 1, I'll get this as y is equal to 10 minus plus minus 2 the whole square is of course 4. So how much is the value of y? Y comes out to be 6. So what you have with you is the point of intersection, and that can be either 2 comma 6 or minus 2 comma 6. That is the point P. Okay, so I'll just consider this and sorry, I'll just consider this and check with the options if I get the final answer correctly. Then for obtaining M1, for M1, let's just differentiate this. So you get this as dy by dx is equal to minus 2x. Let us substitute the first value here. Now, if I substitute x as equal to 2, then I get slope as minus 4. That's going to be first slope. For M2, again, differentiate this. Dy by dx will be equal to 2x. As you know, x is equal to 2. So this is going to be M2, which gives us the value as 4. Now you have M1 and you have M2. So you can obtain tan theta. What is tan theta? Tan theta is equal to mod of M1 minus M2 upon 1 plus M1 M2. So that is equal to mod of M1. What is M1? M1 is minus 4. M2 is 4 upon 1 minus 4 into 4 will be 60. So one is positive, the other is negative. That's why you'll get in this form. This is minus 8 upon minus 15. So your final answer comes out to be 8 by 15. And this is the correct answer. Okay. Now, question number 4. So equation of tangent to the hyperbola 4x square minus 5y square equal to 20 parallel to the line x minus y equal to 2 is. Okay. So you should note that this question has also appeared in the JEE examination again in 2019 January. So in order to obtain the correct solution for this, you have to concentrate on this line. This line is parallel to the tangent. This line is parallel to the tangent. So that's why if I say slope of, or let's start with a different process now. Equation of given line is x minus y equal to 2. Therefore, I can say equation of tangent is going to be x minus y plus lambda equal to 0. Now, why is that? Because when two lines are parallel, their slopes are equal. So that's why this value and this value will be the same. Only change will be in constant value. So I don't know that constant. I have assumed it to be lambda. So x minus y plus lambda equal to 0 is the form of tangent. Now, let's apply step 1. So differentiate the given curve. Given curve is 4x square minus 5y square is equal to 20. Okay. Now, is the point of contact given to us? No, it's not. So you'll say let point of contact be x1 comma y1. Okay, this is our point of contact. Now differentiate this curve. You will get this as 8x minus 10y dy by dx is equal to 0. Now, if you look at this equation of tangent, then you can say that slope of this tangent is 1. Okay, slope of this tangent is 1. As a result, if I substitute point of contact in this, then this is going to be 8x1 minus 10y1 into m is equal to 0. But remember that m is 1. That's why I'll just get this as 8x1 minus 10y1 equal to 0. That is 8x1 equal to 10y1. And therefore, I can say that 4x1 is equal to 5y1. Or I can say y1 is 4 by 5 x1. And I'm going to use that in this equation. Now, why is that? Because this is the equation of curve and point of contact always lies on the curve. So it should satisfy the equation of curve. Now, this value here is going to be 4x1 square minus 5 y1 square. What is y1 square? It is 4x1 by 5 the whole square, and that is equal to 20. So let's just simplify this quickly. Now this will give you 4x1 square minus 5 into 16x1 square by 25, and that is of course 20. You can cancel this out. You can take the LCM. So this will give you how much? 5 into 4, 20 minus 16 means 4x1 square upon 5 equal to 20. So x1 square is equal to 25, and that's why x1 is equal to plus minus 5. Now if x1 is equal to plus minus 5, I can substitute that over here and I can get this as y1 is equal to plus minus 4, because 5 will get cancelled, plus minus sign would remain. So either the point of contact is 5 comma 4, or the point of contact is minus 5 comma minus 4. Now depending on your options, you can substitute any one of the 2 points. See, point of contact always lies on the curve, so it should satisfy the equation of curve. Now as soon as I substitute minus 5 comma minus 4 in this equation of tangent, this equation, then I would get this as minus 5 minus of minus is plus 4 plus lambda is equal to 0. So what is the value of lambda? Lambda comes out to be 1. So what is the final equation of tangent? Equation of tangent then comes out to be, just check this, x minus y plus 1 is equal to 0. And that's why this is the correct answer here. See how easy questions are asked in the JEE examination on tangent and normal. It's one of the most scoring topics, and if you use it properly, if you use the concepts, if you use the techniques properly, if you go step by step, you will always get the answer. Now, let's proceed to the last question in today's lecture. Again, a question that appeared in the 2019 JEE examination. The tangent to the curve y equal to x into e to the power x square passing through the point 1 comma e also passes through the point. Okay, so what you need to do is find the equation of tangent to the curve. Okay, using this curve equation, using this point, and then you need to check which of these points from ABCD option satisfy the equation of tangent. So our procedure should be, let's just begin step by step. Sorry for this. Solution. Let's just start step by step. Consider the equation of curve, that is y is equal to x into e to the power x square. Now, I have a doubt. I don't know. I'm not sure, but I have doubt that 1 comma e is actually the point of contact. See, they are not saying that 1 comma e is point of contact. Had 1 comma b e been a point of contact, they would have said that it is tangent at the point 1 comma e. They have said passing through the point 1 comma e. So this can be a hypothetical situation. See, your curve is something like this. Then you have this tangent t. Now, it's not necessary that the tangent is passing through point of contact exclusively. No, there are multiple points. This can be your point, this can be your point. Maybe this is your point. We don't know. But if I substitute this point 1 comma e, which is given to us, in the equation of curve, and by chance if it satisfies the equation of curve, then I can say that this is the point on the curve as well as on the tangent. So this point has to be the point of contact. I hope this explanation is clear. Let's substitute 1 comma e in this equation. So I'm going to substitute 1 as the value of x. I'm going to substitute x as equal to 1, and I'm going to check if y is equal to e here. So let's substitute that. This will give me y is equal to 1 into e to the power 1 square, that is again 1 into e, that is of course e. So I'm getting 1 comma e. So my instinct was right here. My intuition was correct. So 1 comma e is a point that lies on the curve as well as on the tangent. So 1 comma e is nothing but, sorry, oh, sorry, 1 comma e is nothing but point of contact. Do not just end the video here. We are not yet done with the last question. So you just saw the screen, end of lecture. No, it's not. Just a few points are remaining. Let's just solve them quickly. So 1 comma is the point of contact. Now I'm going to differentiate this curve quickly. So I'll get this as dy by dx is equal to product rule. So e to the power x square plus, derivative of x is 1 of course, plus x into e to the power x square into 2x. Now this is at x equal to 1. Let us substitute that. So 1 comma is the point of contact, x is equal to 1. As soon as I substitute that, it will give me slope. So slope m is of course e plus 1 into e into 2 into 1. Okay, lots of calculations, right? So e plus 2e means that is 3e. That is our slope. So if m is 3e, in the last step, I can apply slope point form. So that is y minus y1, y minus e is equal to 3e into x minus x1. What was x1? x1 was 1. Right. Now, what I can do is I can substitute points one by one. Let us substitute option A. Okay. If I substitute option A here, and I need to check if it tallies or not. So option A is 2 comma 3e. Okay, so this is 3e minus 3 for option A. This is 3e minus e, that is 2e, is our LHS. And let us look at RHS then. RHS comes out to be 3e into 2 minus 1 is 1. So option A is not our correct answer. Let's use option B. Yes, you have to go through that process. So let's substitute option B, 2e minus e, that is e, comma, then 3e into 4 by 3 minus 1 is 1 by 3, right? So this is our correct answer. I hope I have just substituted that correctly. You can confirm. So 2e minus e is e, yes, and 3e into 4 by 3 minus 1 is of course 1 by 3. It gets cancelled, right? Okay. Now, so correct answer is B. And hopefully you have understood the concept of tangents and normals and how to solve problems based on it. Now, that's officially the end of lecture 2. Okay. So if you liked the video, subscribe for more. Thank you so much. See you again for the next part, that is rate measure. So we'll discuss that in lecture 3. Okay. Bye for now.